So guys, let's quickly move to the inclined plane. So friction, static solid friction, so dynamic friction for an inclined plane. So we'll be talking of the movement of the two bodies on this inclined plane. So we are having mass M2. Mass M2 is dragging M1, right? If M2 is dragging M1 with a particular force called tension, right? T, our tension will be the same thing as what? W2, the weight of mass 2 will be the what? The force at which this thing is dragging. So it will be because of our tension. Now, we've gotten our tension to be W2, but when you get here, your tension will no longer be W2. What is happening, Bachelor? This mass, let us have another diagram here. Maybe you're having a particular mass here. You drag it upward. So the mass now move from here to here, here. So movement of here to here. Let's trace it downward. You can see this body, the moment it moves upward here, it increase in length, distance, x axis. It also increase in height, y axis. So if you are pulling something on a climb plane, you are doing two work. You are supplying a force that will let this thing climb up, oh, and the one that will let it move sideways. Be wise. Don't waste your energy. Don't waste your force, man. You don't have a lot of force. So when you're having a W2, which is a force, this force, let me just say, this force is trying. It's supplying tension of W2, but when it gets here, it's split into two. One for vertical, one for horizontal. We are only concerned about the one for vertical. You can see this thing will climb up before coming down. So for us to know the one that is meant for the vertical one, you understand? Remember in our frictional force, we said our force for vertical will be what? W sine theta. And force for horizontal equal to W cos theta. So we only need W sine theta for this. So if we are to go for the force that this body used to go to move what vertically, we use W sine theta. Who is dragging this body? Is not W2? The force of W2 will be W2 sine theta. So let's quickly go. So now, when we're talking about what we are only dealing with this inclined plane here in dynamic friction, we only calculate acceleration. We deal with acceleration. Acceleration of this body. We already know dynamic means something moving, right? When you're talking of something moving, it will move with particular acceleration. So we need to calculate the acceleration, man. So when we're talking about acceleration, we say force is equal to mass times acceleration. So our acceleration is equal to force over mass. So what are the mass? M1 plus M2. What is the force? How are we going to know the force acting on this body? Which one? What is the force that is acting that is pulling this body? W2. But I told you the force will split into two. The force will split into two, one for vertical, one for horizontal. Which one are we now concerned about? We're only concerned about the one that is making it vertically, so we only need W2 sine theta. So we say W2 sine theta will be the force that is acting on this M1. Do you just get me? Should I repeat myself? Yeah, no problem. When we're talking of the weight that is actually dragging this mass, it is W2. The weight of this M2 is dragging this M1. Fine. Good. Now, the force on this M1 now has now split into two. The one is taking it upward vertically, one is taking it horizontally before it can get here. She gets, and we only need the one that is taking it vertically. Since we need the only one that is taking it vertically, the force for vertical is what? W sine theta. Then we quickly use what? W2 sine theta. So part of this W2, you just put sine theta to it. Is the one that is taking it vertically. So that does it. So more even or you can also say M1 sine theta, everything to bracket G. You know, when you multiply M1 times acceleration into gravity, it will give you W2. So then we fool my brother. So let's go. When we go to the rough surface, this is a smooth surface, no friction. That's why we don't talk about friction. Oh, but you are not talking about friction when we are still on friction. Yes, this is a smooth surface. It has limited friction, so we don't need to talk about the friction. So let's go to the second one, which is a rough surface. When we are dealing with rough surface, the force that this M2 is using to drag M1 is still the same thing as what? W2 sine theta. But this one is having friction. Are you telling me their formula is still the same? No, it is not the same. When this is having friction, if you are supplying force of W2 sine theta to take it vertically upward, W2 sine theta, you know where the friction is there. Frictional force F. Friction will be like, I beg. Out of this W2 sine theta, I beg me to one just. I want chop small, sorry. I want chop small. Give me some force. I will not allow you to go. Give me. Come and meet me. Come here. We shall be dragging it in the direction. Before we say, oh man, I want to go, man. So the moment the friction and this thing, they are dragging themselves. How are we going to know the remaining force that is left on this M1? We say the force W2 sine theta that is dragging this body minus the friction that is disturbing them. The remaining will be the force that is there. So our remaining force on M1 will be equal to our force W2 sine theta minus what? Minus this stupid friction. Minus this stupid friction. So remaining force on this M1 will be the what? W2 sine theta minus this friction. What is friction? Don't forget, in inclined static solid friction, our previous video. So what we actually talk about, we said coefficient of static friction equal to frictional force over the W cos theta. When you cross multiply, you say F is equal to coefficient of static friction times W what cos theta. Do you get it? So this will be the formula for our what frictional force. So we will quickly replace this by saying remaining force on this M1 will be what? W2 sine theta minus W2 sine theta minus what is our friction? We say our friction is what? Coefficient of static friction times what? W cos theta. But please wait. Which weight? Is it W1 or W2? Abeg o. Who is friction disturbing? Is it M2 or M1? Friction is disturbing what? M1. So what we will be using here will be what? W1, since we are dealing with friction. But why are you using W2 here? Shebi we are talking of force that is dragging it. M2 is the one that is dragging M1. So we use W2. But now we are talking of friction. Who is friction disturbing? Is it M1 or M2? It is M1. Why? Because M1 is the one that is in contact with another surface. And when there is a contact between two surfaces, remember friction now, it will affect the what? The relative motion of M1. So friction is the opposition in the moment of unit I will explain. So everything is clear. So quickly let's go. Minus our friction, right? Coefficient W1 cos theta. This is a very long formula. Oh, bachelor, how you want me to memorize this? You can get this thing. When you get familiar to it, you know it offhand. You know it offhand. So let's go. You can also say our acceleration here is the same thing as M1, M2 sin theta minus M1 cos theta, everything over everything over M1 plus M2, right? So how are we doing? We will just say everything close bracket, acceleration due to gravity. Because when you multiply G times all of them, they will still give you this. So they are still the same formula. So guys, we are done with dynamic solid friction. These are the formula you're supposed to know in the dynamic solid friction. But sometimes you will be asked to calculate the tension on the rope. Oh, what the fuck is this, bachelor? What the fuck is this? You are asking me to calculate the tension of the rope. Oh man, it's fucking simple. It's fucking simple. So what we're going to do when we need the tension on the rope, let's deal with it this way. Maybe we have for the smooth surface. This one will be for the rough surface. This one will be for the smooth surface. Now for the smooth surface, what will be the tension on the rope? Our tension on the rope is T, right? Tension on the rope is T, which is the same thing as W2. Yes. What is our friction? We do not have friction. Oh man, no friction. So what will be the tension on the rope? Wow. W2 is the total force that is being supplied, right? So the force that is taking it vertically will be what? W2 sine theta. So our tension here, you understand, is equal to what? W2, right? Now, at here, tension, let me just say T1. Now, T2. Tension here, T2. Now, T2. This one is T2. Tension here, which is T2, will be equal to, it is the force that takes it upward, right? So the force that is taking this particular mass upward will be what? T will be what? W2 again, but sine theta. Do you get it? So there is no friction, no problem. No problem. What will not be the force acting on this mass? The force acting on this mass, it is the same thing as T2. So we can just say our force or mass times acceleration on this body will be equal to W2 sine theta. That's just it. Mass acceleration acting on this body will be equal to what? W2 sine theta. So we don't have any issue, bro. So now for the rough surface, yeah. Fuck. What the hell is this? Okay, let's go. So we are having our acceleration. Yeah. So for the rough surface, this is for the smooth surface. Now we're talking about the rough surface now. For the rough surface, we're having our T1 and T2. Let's say this is our T1 and this is our what? T2, right? This is our T2, tension on the rope, second one. So tension on the rope here, T1 is the same thing as what? T1 is the same thing as what? W2. Fine, we know that. But tension here on this rope, tension on this rope is now T2 equal to W2 sine theta. Yes, we know that. Now, what is the remaining force that is on this thing? The remaining force on this mass after friction, you know there is friction here. The remaining force on this mass, let's represent it to the remaining force equal to what? Mass times acceleration. Now, what is our frictional force? Frictional force F. How are we going to know the remaining force? We say we minus the frictional force from the force that is dragging this, as we explained in the previous time. So you just say the remaining force, which is equal to what? Mass times acceleration. You understand? Or you say your mass times acceleration, which is the remaining force, will now be equal to what is the original force? Or the original force is what? Uh, W2 sine theta. Now, what is our friction? Don't forget, formula for friction. I think I calculated it here. W cos theta. You just say our friction force that is dragging this thing upward, which is W2. Let's put it somewhere here. Let us put it somewhere here. Sorry for erasing this. I hope you've written this. If you have not written it, just go back to the just move back to the video so you get it there. So let me put it here. So we have we are having our remaining force to be what? Mass times acceleration. Yes, and mass acceleration equal to the force remaining on this will be equal to what is the force that is supplied to this? Go, 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 go. It is W sine theta. W2 sine theta minus what is our friction? Our friction is what? Friction is what? U W cos theta. So U W cos theta. Which W? W1. So the tension on the rope. The tension on the rope. You know, this is W sin theta, W2 sin theta, which is the tension on the rope, T2. You can now rewrite it like this, that mass times acceleration equal to our tension on the rope, T2, minus UW1 cos theta. So you can rewrite it this way. So this is the formula to get the tension on the rope. Yeah. So just say mass acceleration equal to W2. That's the only thing they can ask you to calculate. Just write down those formulas that are in brackets and memorize them. So let's move to the question section. So we'll get to the question section. We are going to do with this and solve a lot of questions as much as possible as we can. So thank you guys. I hope you have subscribed to the channel. I hope you have subscribed to this channel. Go and subscribe. Subscribe. I want I want you to subscribe. Please subscribe. So when you subscribe to this channel, just like make sure you watch the video serially. You understand? When you watch this serially, you get to know things better. So watch out for solution on this topic. So let's go, guys.